Okay, let's keep these examples coming. We have this object sliding down. There's now friction. Okay, so hopefully we're starting to get a handle of these. We have force of gravity is going down. That's force of gravity. It's got an x and a y component. So the x component, Fgx and Fgy. What we need to make sure we understand is like Fgy and Fgx, they're not force in themselves, they are components of force of gravity. We have normal force and we have friction force. Okay, so we actually created this equation previously. We saw that in the x direction, some of the forces in the x direction is equal to max, and it's the force of gravity trying to bring this box down, but the force of friction is trying to slow it down. And friction always reduces that acceleration, always opposes motion. There's our equation for that one. And before us to be able to solve for force of friction, though, we need to find out what the normal force is. Sum of the forces in the y direction is 0. It's not accelerating in this angled y axis direction. We know normal force is being opposed by a force of gravity in the y direction. So you have normal force is equal to Fgy. And we can simplify that. Force of gravity is mass times gravity. The y component is going to be that sine. Sorry, not sine, it's going to be cos. My bad, sorry. It's going to be that. Here's our 30. It's going to be cos 30 degrees. So that's our normal force. So now if we go back to our x direction, we have max. Fgx is going to be mg sine 30 degrees. And it's minus our force of friction. Our force of friction is the coefficient times our normal force. So we get our coefficient times that normal force, which is mg cos. So at this point we just plug in our numbers. If you want, we could simplify it a bit. We can see that, oh, mass is in each term, so they can cancel out. Find out in the x direction, it's going to accelerate. We have g sine 30. We can actually factor out that g as well if you want. We get sine 30 minus the coefficient times cos 30. Let's plug in. So we have sine 30 minus 0.2 is our coefficient times cos 30 times 9.81. We get an acceleration of 3.21 meters per second squared.